Global warming and ozone depletion. The Earth's atmosphere is a layer of gases surrounding the planet Earth that is retained by the Earth's gravity. The Earth's atmosphere consists of many layers. They are starting from near the Earth's surface. One, troposphere, which extends between 7 kilometers at the poles and 17 kilometers at the equator. Second, stratosphere extends from where the troposphere ends to about 50 kilometers. Third, mesosphere extends from where the stratosphere ends to a range of about 80 to 85 kilometers. Thermosphere. This extends from where the mesosphere ends to about 640 kilometers. Fifth, ionosphere. It starts where the thermosphere ends to about 500 to 1000 kilometers. Exosphere extends from where the ionosphere ends to about 10,000 kilometers. The Earth we live in is undergoing a gradual change of weather, and as technology and industrialization advances, the negative impact of it to the world is beyond imagination. The changing weather conditions with the increase of global temperature and its implications are becoming more and more dangerous to life on Earth. There is an increase in the average temperature of the Earth's surface, air, and oceans in the recent decades, causing global warming. The ecosystems of the Earth are changing due to the ever increasing activities of human beings. The ecosystem, also called the biosphere, is an evolutionary system. An ecosystem is a natural unit consisting of all plants, animals, and microorganisms in an area functioning together with all of the non living physical factors of the environment. There exists a delicately balanced cycle between these various factors within the ecosystem. It is therefore absolutely necessary that these cycles should be maintained unimpaired. Over the last 3 decades, the global surface temperature has increased by approximately zero point 0.6 to zero point 0.8 degrees Celsius. That's about 1.1 to 1.4 degrees Fahrenheit. This increase is part of a longer term warming trend observed since the late 19th century, attributed largely due to the rise in greenhouse gas emissions from human activities such as burning fossil fuels and deforestation. This trend is documented by various climate monitoring organizations around the world, including NASA and the National Oceanic and Atmospheric Administration (NOAA). This climate change is noted as global warming. The effect of greenhouse gases on global warming is the most important environmental issue facing the world today. These gases include carbon dioxide, water vapor, methane, nitrous oxide, ozone, and chlorofluorocarbons. The fundamental energy source for our planet is sunlight. However, 30% of the sunlight is reflected back to space by clouds, atmosphere, land, and sea surface, including sea ice, ice sheets, etc. The Earth is warmed by the remaining 70% and in turn radiates the heat as infrared energy or the heat radiation. Climate is governed by the balance between the incoming solar heat and the cooling associated with the outgoing infrared energy. As the population on Earth increased, the amount of carbon dioxide in the air also increased considerably. By breathing out carbon dioxide and by burning of fuels, fossils, and biomass, and as smoke from automobiles, engines, factories, etc. The terms global warming and climate change are often used in place of each other, though both are different. Actually, climate change is due to global warming. Gases such as carbon dioxide, methane, nitrous oxide, and refrigerants create a greenhouse effect by trapping heat in the lower atmosphere. This makes the Earth warmer because the sun's rays are allowed into the lower atmosphere. But the heat from these rays, also known as infrared energy or heat radiation, isn't able to escape. As of the last update, the Intergovernmental Panel on Climate Change, that is IPCC, has released the sixth assessment report in 2021 and 2022, which consists of contributions from its three working groups. Here are some key findings and messages from the recent IPCC reports. 1. The warming levels. The Earth's surface temperature has already risen by about 1.1 degrees Celsius above pre industrial levels. Second, human influence. It is unequivocal that the human influence, particularly the emission of greenhouse gases, has warmed the atmosphere, ocean, and land. Third, impacts. Climate change is already affecting every inhabited region across the globe with heat waves, heavy precipitation, droughts, and other extreme weather events becoming more intense and frequent. Fourth, future projections. Without immediate rapid and large scale reductions in greenhouse gas emissions, global warming of 1.5 degrees centigrade and 2 degrees centigrade will be exceeded during the 21st century. Fifth, sea level rise. Continued warming will lead to increased sea level rise. Even if global warming is limited to well below 2 degrees Celsius, sea level rise will still continue into the century. Sixth, mitigation. Limiting global warming will require mass transitions in energy productions, land use, transport, and building infrastructure. It also necessitates technological and behavioral changes. Seventh, adaptation. While mitigation is crucial, adaptation measures need to be accelerated to manage the risks of climate change that are already occurring. These findings reflect the latest consensus of the scientific community regarding the causes and consequences of climate change, and they emphasize the urgency of global action to mitigate and adapt to these changes or related new sources is recommended. As of the last update, the concentration of carbon dioxide in the Earth's atmosphere has surpassed 410 parts per million. That is a ppm. This measurement is typically expressed in ppm, meaning that for every 1 million air molecules, more than 410 are carbon dioxide molecules. In terms of percentage, 410 ppm translates to 0.041 percentage of the atmosphere. Historically, before the Industrial Revolution, CO2 levels were about 280 ppm, that is 0.028 percentage. The rise in CO2 levels over the past century is primarily due to human activities such as fossil fuel burning, deforestation, and industrial processes. It is also important to note that the CO2 concentrations continue to rise each year, largely driven by human activity, and the numbers may have changed as of today. Human impact is the cause of the rapid increase in carbon dioxide. The lifetime of carbon dioxide in the atmosphere is over a century. The carbon dioxide in the atmosphere acts like a woolen blanket, um, trapping the outgoing infrared heat within the atmosphere, causing the planet to become warmer. All living beings breathe in oxygen and breathe out carbon dioxide, thus making the air impure. But nature has its own method of purifying air. Green leaves of plants absorb carbon dioxide from the air, and in presence of sunlight, they manufacture starch using the water and minerals taken from the soil. This process is called photosynthesis. During this process, oxygen is given out, thus air is purified. But as the population increased, the human beings, in their quest to find place to live and cultivate, started deforestation, which involved cutting down trees and plants. The main reason for deforestation was for inhabitation and to obtain timber for building houses and furniture. Also, deforestation facilitated acquiring land for factories and various other industries. Deforestation is one of the main causes of the accumulation of carbon dioxide in the atmosphere. The increased burning of fossil fuels like coal, shale, and oil, and also inorganic deposits like carbonates, etc., release carbon dioxide into the air. Over the years, more and more volumes of waste carbon began to accumulate in the atmosphere, mainly due to the expanding industrial activity. This accumulation of waste carbon in the atmosphere has started acting like an opaque wall above the Earth, preventing the entire radiation to escape into space, and hence it is getting progressively warmer on Earth. Stratospheric ozone is Earth's natural protection for all life forms as it acts as a shield for our planet from harmful ultraviolet B radiation. Ultraviolet B radiation is harmful to humans, animals, and plant life. Oxides of nitrogen and water vapor are released by supersonic jets flying through the stratosphere, and the gases formed by the increased use of nitrogen fertilizers for agriculture contribute to the breaking down of ozone molecules in the air. Consequentially, it depletes the ozone layer and the ultraviolet rays impact the Earth's surface. The ultraviolet rays decompose the chlorofluorocarbons, CFCs, used in air conditioners, refrigerators, aerosols, solvents, and in propellants, etc., releasing chlorine, which in turn depletes the ozone and damages the ozone layer, allowing the ultraviolet rays to penetrate the atmosphere and reach the Earth's surface. The damage to the ozone layer due to its depletion is much higher when the stratosphere is very cold. The depletion of the ozone layer permits the ultraviolet B radiation to reach the Earth's surface. Ultraviolet B radiation causes skin cancer, cataracts, and immune suppression in both animals and humans. Ultraviolet B radiation also damages plants, including hardwood forests and phytoplankton, which is a type of algae which forms an important component of the oceanic food chain. As of the most recent updates, the UNEP, the United Nations Environment Program, has been involved in various initiatives focusing on climate change, biodiversity, pollution, and sustainable development. Some ongoing themes include the UN Decade on Ecosystem Restoration and efforts to address plastic pollution and promote a circular economy. The recovery of the ozone layer is an ongoing process and has not been fully replenished yet. However, significant progress has been made. The Montreal Protocol, adopted in 1987, aimed to phase out the production and consumption of ozone depleting substances such as chlorofluorocarbons, which are the CFCs. Thanks to the international cooperation and compliance with the protocol, the ozone layer has been gradually been healing. According to assessments by organizations like the United Nations and the World Meteorological um, Organization, if current policies remain in place, the ozone layer is on track to recover to pre 1980 levels by around the middle of the 21st century, specifically by the 2030s in the northern hemisphere, the 2050s in the southern hemisphere, and slightly later over Antarctica. Continued adherence to the Montreal Protocol and monitoring of atmospheric conditions are crucial to ensuring this positive uh, trend continues. Ozone depletion happens more when that stratosphere, that is where the ozone layer is, becomes colder. Because global warming traps heat in the troposphere, less heat reaches the stratosphere, which will make it colder. This entrapment of heat by the greenhouse gases in the troposphere will result in the stratosphere getting colder. In other words, global warming can make ozone depletion much worse. There are several harmful impacts that result from a global warming trend. Impacts from global warming include rise in sea level, more extreme weather conditions including heat waves, frost, droughts, storms, extinction of species and loss of entire forests, marine life destruction and glacial retreat. Ozone depletion and global warming have harmful effects on plants and animals. If allowed to continue, our food chain will be seriously disrupted. For example, phytoplankton are tiny floating algae in the ocean, which are the base of the marine food chain. In Antarctica, there has been more than 50% ozone depletion. This means that an unusually high amount of UVB radiation has reached the Earth's surface in the Antarctic region. The ultraviolet B radiation harms the productivity of phytoplankton, thereby reducing the available food for animals that feed on phytoplankton. When we view the effect from the perspective of climate change, phytoplankton normally absorbs a lot of carbon from the air. As phytoplankton dies from the ultraviolet B radiation, this carbon is no longer absorbed. This means that more carbon will be left in the atmosphere, resulting in more global warming. More global warming can increase ozone depletion, which kills more phytoplankton, and the cycle continues. Most infectious diseases are transmitted by insects and rodents. Transmitters of disease are called vectors. For example, mosquitoes transmit malaria, dengue, and viral encephalitis, which is the inflammation of the brain. Like other animals and plants, vectors are accustomed to certain climate conditions. If the climate becomes warmer, the mosquitoes will fly to new places where it can survive and expose more people to the disease. Changes in sea surface temperature and sea level can lead to higher incidence of waterborne diseases and toxin-related illnesses such as malaria, which has severe chills and fever, cholera, which shows EH's intestinal disease, dengue, characterized by severe pains in the joints and backs, and skin ulcers. Due to the destruction of food sources, humans will be more prone to infections due to malnutrition. Ultraviolet B radiation from ozone depletion damages both plants and animals. Crop-soil damage will reduce food availability. Ultraviolet B radiation can also cause damage mammalian immune systems, which makes humans and other animals more susceptible to infectious diseases. Let us wake at this crucial moment of our era to protect our Earth from the hazards of global warming due to pollution by analyzing the cause of this problem and create an awareness about it globally through debates, seminars in schools, colleges, and other institutions, and educate the public the role of each individual for minimizing the pollution and maintaining a healthy atmosphere. Some suggestions to reduce pollution and thereby reducing the global warming is by afforestation, which is planting trees and plants. A car and two-wheelers can be run by batteries, etc. This is also There's also a realization that pollution is a part of the development and two cannot be separated. So a compromise has been marked out sustainable development. This development occurs, but not at the cost of polluting and destroying the hope of future generations. Every delay in an action now against global warming and ozone depletion will endanger the future of the planet and result in a situation where our future generations will find it more and more impossible to survive and replenish. If indeed technology has created this problem, then let us also use technology to solve the problem, as stated by a former UN Secretary General. Please don't forget to subscribe and to like and share this video so that I can make more useful videos in the future. Thank you.